Hi everyone, welcome to Mathematics 0110. Also welcome to Kings. My name is Dr. Joseph Turnbull, and I'll be your instructor if you're inside section 270. My colleague, Dr. M. Valeri, will be your instructor if you're inside section 271. This is a team-taught course, so everyone in both sections has access to all materials that both of us create. You will also write common tests and exams. The textbook for this course is a custom text. It's not available yet. It should be available next week or the week after. It's a brand new book. It's going to be available in two formats, the usual print format and an ebook. The ebook is half price, but it's only a rental. You only get access to it until the end of August 2021. As soon as that purchase information is available, I'll post it to the L page and make an announcement. So be on the lookout for that. I've been asked a few times, is it okay if you purchase a used book? Absolutely, you can use the book from last year. It'll work fine. I'll post the homework for that. Another question related is, do I need a new book so I have an access code? I know some courses have this feature where in order to access the quizzes or something like that, you need to have the textbook so you can have an access code. That's not the case for Math 0110. There are no access codes that you'll need. And then the next most common question that's been asked over the last few days is, do I have to come into class? Absolutely not. You've been guaranteed the ability to complete your courses remotely. For, I believe it's all classes at King's, but certainly this class. Your tests are going to be online. We're going to put all this material online, notes, practice tests, the whole deal. However, after these next 2 weeks, which we're just going to see what happens, it's a safety measure. We're going to roll out in-person classes gradually. If the next 2 weeks go well, we will have some type of in-person learning. What I think that's going to look like is problem-solving, question-answer, and tutorial-type sessions, although I'm open to suggestions. There are about 65 students in my section. There's about 45 students in Dr. Valeri's section, so over 100 students total. The problem, one of the many problems, but the big problem that we have is that classroom capacities have been reduced substantially in order to have social distancing. So a classroom that normally holds 120 students can now only hold 25 students. A classroom that normally holds 100 students can now only hold 20 students. That means we have to do something like a staggered attendance, unless not very many people want to come to class. We'll see what happens. If you want to participate in the lecture but you're not able to come to class, there will be a way that you can do that remotely. There'll be a way that we'll have streaming with interactivity. So either broadcast over Zoom or broadcast over some other platform. So you can ask questions during the class and that type of a thing. Office hours are normally held in an office. We've been told that is a very bad idea this year, and I agree. So our office hours are all going to be held remotely. That means we'll be using Zoom or Collaborate, or a few brave souls will be using Discord. I'm one of them. I'll try the Discord thing. If it starts going sideways, I'll have to go back to Collaborate. I don't like Zoom. Too many meetings with Zoom already. I don't want any more. The virtual office hours are not the only way that you can get help. You can also get help by posting to the L forums. That may actually be the most convenient way because it's open 24/7. There's also going to be a School of Management, Economics, and Mathematics Help Center that will start next week, staffed by senior undergraduate students at King's, and they're going to be offering help for this course, Math 0110, as well as Math 1229, Business 1220, and Economics 1021, and I believe Math 1228 and Stats 1024, but don't quote me on that. That's being sorted out right now. If we have in-person classes, what are we going to be doing? Probably like I said, review session or tutorials, question and answer, or review sessions prior to a test. The first thing you should do when you start all your classes is to look at that course outline. The course outline is a contract. It's a contract between you and your instructor. And what it lays out is what your expectations should be for the course and what the instructor is expecting for you. They're usually quite long, like many, many pages. I've seen course outlines that are 30 pages long. That's horrible, but read it anyway. It doesn't matter how much is in there. Read the whole thing. There's important dates. For example, our course outline indicates that you have 3 tests. They're all on Saturdays. They're all at 7 to 8:30 p.m. Eastern Time. And their dates are indicated here as well. October 3rd, October 24th, November 14th. Put them in your calendar. Make sure you book those times off. You can set aside 1.5 hours at 7 p.m. on those evenings. The weight of each of those tests is 17% of your final mark. 19% of your final mark then comes from assignments and quizzes. You're going to have something due approximately every week. Some weeks you'll have 2 things that are due. The last part of your mark comes from the final exam in December, which is going to be worth 30% of your final grade. All these assessments are going to be completed online. Again, you don't have to come in for anything. You can do it. You do the entire course from the Bahamas, or you can do the entire course from, I think we have students in Ghana, we have students in India, China, all over the world. So wherever you are, even Chatham, you can complete your coursework from there. So they're online. Does that mean they're all multiple choice? No, it does not mean they're all multiple choice. Multiple choice is not the best way to test math. Many of your questions are going to be long answer. How do you answer a long answer question online? Excellent question. You need paper, you need a pencil, and you need some type of device to take a picture, like a smartphone. What do you use to take your picture with? Don't use your photo app because you'll get a gigantic JPEG. One page might end up being like 8 megs or 12 megs. I've seen 25 megabyte single images trying to be uploaded to OWL, and it's really slow. What you should use instead is, for Android, use an app called Genius Scan. For iOS devices, use an app called Scannable. Now, because the name Scannable is, I think, not unique, it's the Scannable created by Evernote that you want to use. For some things, you're going to need a webcam and a microphone. And I'll tell you more about that later. These are 2 different tutorials for how to upload handwritten work for assessments. On the left-hand side is the instruction set for using Scannable. So if you're using an iOS device, on the right-hand side, the instructions if you're using the Genius Scan for Android devices. If you get stuck, let me know. Send me an email. So I mentioned we're going to have quizzes or you're going to have something, at least one thing every week. That minimum one thing is going to be an assignment or a quiz. You'll also have tests some weeks, so that's what I meant when I said some weeks you'll have 2 things. You'll have an assignment and a test, or a quiz and a test. Your quizzes are all going to be open on Saturdays, with the exception of the intake quiz, which opened today. Today's Tuesday, in case you're watching this a different day. The quizzes are all going to be due on Fridays, including the intake quiz that opened today. So Fridays at 11:50 p.m. Eastern Time. The assignments are also going to be due on Fridays at 11:50 p.m., but they're going to open at different dates. There are 9 quizzes in addition to the intake quiz, and 2 assignments. And one of the assignments is a video assignment where you have to make a video. And the other assignment is a formula sheet assignment, that you'll create a formula sheet when you're studying for your final exam, and you'll share that formula sheet with the entire class. So it's formulas, examples, and that type of a thing. Anything that you would really want to have at the ready easily accessible when you're writing the final exam. So everyone basically makes a giant set of study resources for the exam they're going to write in a few days or in a week or whatever it is. Now, I mentioned the intake quiz. The intake quiz does not contain material that's new. It actually contains addition and collecting like terms. So, what's 2 plus 3 is one of the questions. I can't remember what letter is used, but what's 3x plus 4x? What's that equal to? So those are the types of math questions that are on that quiz. And it's not really about asking the questions, it's about making sure that the questions are displaying correctly on your device, on your computer. The intake quiz also requires that you provide a handwritten, photographed, or scanned document. And that's to make sure that you're able to upload stuff and that you can follow those instructions in a type of assessment that has very low weight. It counts for marks, but it should be low stress. It should, if you're not able to upload it, don't stress out. Send me an email. We work through whatever it is that's stopping you from being able to upload the document so that you're able to do that. So that when we come to a test or a full quiz, there won't be problems. That's what the intent of the intake quiz is. And also as a survey, I want to figure out what your technology situation is and what your environmental situation is. Do you have a space where you're going to have privacy to write and a final exam for 3 hours? And those types of considerations. Okay, your tests being all open book means you need good notes. You will not have time during the test to go hunting through the textbook. You won't have time during the test to go looking through all the online notes, look for the formula that you need. You need to have all the stuff written down. Tests have to be done independently. Tests and exams will contain multiple choice questions. Now, some of these multiple choice questions will say, also show your work and upload the calculation. And then there's some traditional long answer questions where you do the entire calculation in pencil and paper and upload them. So it's a mix of question types that you should be expecting. We're going to post practice tests and practice exams. Unfortunately, they are of a different format. They're from the old pre-COVID-19 days when we had in-person tests. So they're a little bit longer than your test is going to be. Your test will have fewer questions. The format's a little different. On those ones, you didn't have to show your work for multiple choice. On yours, that you do. And the mix of questions will be slightly different as well. You're not obviously going to have formula questions like you would have had in a previous year's test that was closed book. It doesn't make sense to ask that if it's an open book test. And we'll highlight those differences as we go through. Why are you here? So why are we all, why am I here? What's the meaning of life? I don't want to get too philosophical, but what I mean by why are you here is why are you taking this class? Why are you taking calculus in the first place? In particular 0110. Very few people take this class because they want to. You're probably taking this because you need to, because it's a prerequisite for some other course. Math 1228, Stats 1024, and I recommend taking Math 109 as a prerequisite for those two instead of this. They're more relevant. It's more relevant for those. Calculus 1000, this is definitely a perfect course to take as a prerequisite. Math 1230 or Math 1225. So if you need one of those courses to get into your module, to get into your program, it makes perfect sense that you're taking this class. But that doesn't really answer the question, does it? Why do you need to take calculus to do your program? Maybe your program is management, you want to do human resources. Or maybe you want to do, let me think of another program that requires a calculus course. Well, maybe initially you may not think that there's a clear answer to this, but economics, if you want to study economics, why do you need calculus? The typical answer that's given is because calculus is directly useful inside these areas. It gives you some tools that you can use to solve problems. And it's not that it's a wrong answer, but I think it's a dishonest one. A more important reason for why you're taking this course is because it helps you understand some of the biggest ideas that have shaped society and continue to shape society. Ideas that will play a big role in the future, forever. So that's mathematics and that's calculus. But even that's kind of that's not doing it justice either. I think the most important reason why you take mathematics is that it helps you think. It helps you learn how to think, how to solve problems, how to structure an argument. Other courses do these things, but mathematics does them in a particular way. If you've ever trained for a sport, you've done weightlifting, it's like a type of isolation exercise. You're developing one particular set of intellectual muscles. And mathematics it's like customized to do that. And it does it very, very, very well. And I think this is the most important reason that so many programs require mathematics, just to give you that training. Going into this class, there are those prerequisites on functions. So it's expected that you've taken a grade 11 math course, or grade 12. So in Ontario, if you took grade 11 university functions or grade 12 advanced functions, both university level, then you're good. If you took college level functions or you took mixed functions, this is going to be a struggle for you. You're better off taking Math 109A and then taking Math 0110B. If you're from another province, your course may have been called Pre-Calculus 11 or 12, or College Algebra 1 or 2. If you're from other countries in the world and you're not sure if you have the prerequisites, send me an email. I'm pretty familiar with all the different math systems that there are, and I'll be able to tell you if you're good to go or not. But typically it's math at the grade 11 level that we assume as a background. And there's a whole bunch of stuff within that grade 11 math and within earlier mathematics you have to come armed with as you start the course, like knowing what is the x-axis, what is the y-axis, knowing some exponent laws. We're going to review those because they're so important, but when I say exponents or exponent laws, some memory should exist in your mind for those things. Maybe it's a bit rusty, but you should know a little bit. Working with fractions is important. Some of that should, making common denominators, and if you have a over b times c over d, how do you multiply those two fractions? Those types of operations, we're going to be kind of jumping right into that. But as with almost everything we will review, the review will not be sufficient for learning it for the first time, but it should be enough to help you overcome any cobwebs that are inside your mind. We do a lot of factoring in different parts of the course. I'll review how to do factoring. We typically do simple factoring that you can use a product and sum method or difference of squares method. We do a lot of work with rational expressions, with fractional expressions, like a top function over bottom function, so you have to be comfortable with that. There's something called the Math Readiness Assessment that you may have been bothered about during the summer. If you haven't done that already, please log into the Math Readiness Assessment on OWL and complete it. If you have no idea what I'm talking about, you've never heard of this thing, and you don't have access to it on OWL, send me an email. I'll add you to the Math Readiness Assessment. It's not for marks. It's not going to kick you out of the class if you fail it. It's not for any of those things. It's to help you figure out where do you need help. The second thing to do to tell if you're prepared is to look at the Functions Bootcamp material. This is on the same page as this video, and it contains a set of tutorial. It's like a tutorial question format with some homework at the back. If you can work through that without much effort, you're good. You're going to have a good time. If you are struggling on it, you still may have a good time. It's not the end of the world. The end of the world is looking at that stuff, saying, I have no idea what this is, completely struggling on it, and then not getting help. That's the disaster. Arguably, that content inside the Functions Bootcamp material is the make or break content. That if you know that stuff, this course is going to go well. If you don't know that stuff, this course is not going to go well. There's enough time at the beginning to get caught up though. I'm going to post solutions to that a bit later. I'll wait a few days, post answers, probably on the weekend, and then check your answers against the answers that are posted. Don't copy them though. Like, don't copy out the answers. Don't transcribe onto paper what you see written out. That's not helpful. It's misleading to you. So an expression like the top one, 12x to the 6 plus 6x to the 4 plus 6x cubed plus 9x, to common factor this means essentially to divide each part of this expression by something. The largest number that you can divide each piece by such that a fraction is not created, and the highest power of x you can divide each piece by such that no negative powers are created. So for this, I have a 12, a 6, a 6, and a 9. I want to divide each of these by some number, the largest number that I can that won't create a fraction in any of them. And the answer is 3. I can divide each of these by 3. I can divide the first 3 by 6, but then the last one, 9, if I divide that by 6, I'll create a fraction, so I can't do that. So I'm going to take a 3 out. And then what am I left with? Well, I also have to take the highest power of x out that appears, and that's x to the power of 1. So I take 3x out. Now what am I left with? To get what's left for the first term, I take the 12x to the power of 6 and divide it by what I factored out. So 12 divided by 3 is 4, and x to the 6 divided by x to the 1 is x to the power of 5. And then I do that for the next term. 6x to the 4 divided by what I factored out, divided by 3x, gives me 2x to the 3. The next term, 6x to the 3 divided by 3x is 2x squared. And then the last term, 9x divided by 3x is 3. Now that's fully common factored. The expression in brackets has power 5, and there's a guarantee that this can be further factored, but we won't do that. We'll do common factoring, we'll do quadratic factoring, and difference of squares factoring, and that'll be it. Okay, next example can be done in different ways. What I'm going to do is I'm going to start by expanding. Well, actually, I lied. I'm not going to start by expanding. I'm going to start by getting rid of the equal sign on the right-hand side because I need more space than what is available there on the right. Okay, so first part is multiply the x into the bracket. So I have a 3 times x squared. X times x squared is x to the 1 times x to the 2. The exponents add. You get 3x to the power of 3. X times 4x is 4x to the 2. And then x times 1 is x. And now the second term in the expression, the 2x squared multiplied by that bracket, I'm going to expand that in. So negative 2x squared times 1 is negative 2x squared. And then negative 2x squared times negative 2x is positive, since negative times negative is positive, 4x to the power of 3. All right, and then we're not quite done. We have to collect like terms. I have a 3x to the 3 and a plus 4x to the 3. That'll be 7x to the power of 3. And then 4x squared minus 2x squared, that's plus 2x squared. And then a lonely plus x, which is not combined with anything. I cannot subsequently combine the 7x to the 3 and the 2x squared, or the 7x to the 3 and the x, or the 2x squared and the x. I can't do any further combinations because these are no longer, these are not like terms. They have different powers of x on them, so I can't combine them. However, I can now common factor this. I can common factor an x out. I can't take a 7 out, and I can't take a 2 out because it'll create fractions in the other terms. Taking an x out is fine though. The first term we're left with a 7x squared, the second term a 2x, and the last term a 1. The boot camp tutorial sheets go through more examples like these and explain some of the steps in a little bit more detail. Okay, factoring. There are many ways to factor. I'm going to show you one way that will work for all the types of factoring that you're asked inside this class for quadratics. So we're asked to factor x squared plus 5x plus 4. You can start by attempting the following. I want to factor this into two linear terms. Since the coefficient in front of the x squared is a 1, I'm going to guess that each of the leading terms in the factors are just x. Because when we do our FOIL, first times first, outside times outside, inside times inside, last times last, the first part of our FOIL, the f part of the FOIL, the x times x, is going to recover the x squared. Now I'm going to use the product and sum method. I'm going to label this number A and this number B. And I want to choose A and B in a particular way. I want to choose A and B such that A plus B equals 5 and A times B is equal to 4. I want to find a combination of A and B that will do that. So you think, okay, how do I get 4 if I'm multiplying two numbers together? 2 and 2, but 2 plus 2 is 4, not 5. How else can I get 4 by multiplying? How about 4 times 1? Well, that works. And 4 plus 1 is 5. Hey, there it is. So x plus 1 and x plus 4. That's our answer. So that's called the product and sum method. To check, you FOIL. So I'll do that for this example and then let you do it for the other examples. How do we FOIL? Well, to FOIL means we do first times first. So x times x, that's the f. And now O is outside times outside, so x times 4. I'll write that as 4 times x because it's more normal looking. And then inside times inside, plus 1 times x. And then plus last times last, 1 times 4. Simplify, x times x is x squared. 4x plus 1x is 5x. And 1 times 4 is 4. And this is what we had originally, so it worked as needed. Okay, next example. X squared minus x minus 2. I'm going to start the same way. X and x. I need A and B such that A times, or I'll do the same order, such that A plus B is equal to minus 1. That's a coefficient in front of the x. It's negative 1. And then A times B is negative 2. It's easier to start with the product. The A times B is equal to negative 2. What two numbers multiply together to give you negative 2? Well, negative 2 and positive 1, or positive 2 and negative 1, but you want the combination that adds to give you negative 1. So that tells you it must be negative 2 and plus 1 as your factors. And if you want to check, FOIL it out and make sure you recover what you had originally. Okay, next one, difference of squares. You can actually solve these the same way as above. I'll write it underneath. I'll call it the alternative, and yeah, I'm doing the alternative first. Then x squared minus 9 is actually the same thing as x squared plus 0 times x minus 9. Just 0 times x, that's the coefficient in front of x. It's a 0. Now let's think about the product and sum method. We want a plus b to equal 0 and a times b to equal negative 9. So a times b is negative 9. Well, it could be negative 9 and 1, but those don't add to 0. It could be positive 9 and negative 1, but those don't add to 0 either. What else could it be? Well, it could be negative 3 and positive 3, and those do add to 0. So according to the product and sum method, we get x minus 3 times x plus 3. Okay, here's another way to do these. It's a bit faster, and that's, or use the fact that x squared minus a squared, where a stands for anything, is x minus a times x plus a. Foil it out and confirm that that's the case. So if we use that here, we're going to get the same answer we already got, but using this special formula, x minus 3 times x plus 3. The order, by the way, doesn't matter. Just like the other two examples above, the order of that multiplication does not matter. If you said that the quadratic factors, the quadratic x squared plus 5x minus 4, or plus 4 factored into x plus 4 times x plus 1, if like you reverse those, that's also correct. And the reason it's correct is that the scalar quantities don't care about order of multiplication. So functions and numbers, you can multiply them in any order and the answer won't change. Anyway, let's use a shortcut in the next problem. X squared minus 36, well, according to this is x squared minus a squared. A is 6, since 6 squared is 36. So this is x minus 6 times x plus 6. I'll add one more underneath. What's x squared minus 10? Okay, you may say, well, I can't use this special method because 10 is not something squared. But you're wrong. 10 is the square root of 10 squared. So we can still use this method. It's x minus square root 10 times x plus square root 10. You may have seen that before, but have you seen this before? X minus 10. What now? First question you should ask is, why are you factoring that? That's fine. Leave it alone. My response to that is no. You don't always leave it alone. Sometimes it's not good enough. Sometimes you do factor it. I'll show you how. Can you write x as something squared? Yes. The square root of x all squared. So you can factor this as root x minus root 10 times root x plus root 10. Making sure that each of those two things are in separate square roots. You cannot combine them. You can't say that the left bracket is root x minus 10 all in one square root. It doesn't work like that. With a provision here that for x positive or 0, so no negative x values because you can't take the square root of a negative number. Right, and the last thing I want to review inside this video is fractions, how to work with them. So the first question, 3 over 4 plus 2 over 3. How do you add a fraction, or how do you add two fractions? In order for them to be added together, they have to be measuring the same quantity. So you need common denominators. This is going to be easy. The easiest way to get to common denominators is to take the denominator of one fraction and multiply the top and bottom of the other fraction by that number. So I'm going to take the 3 that's in the bottom there, put a little color cloud around it. So I'm going to multiply and divide by 3. I'm multiplying by 1, so I'm not changing the value. Then plus 2 over 3, and now I'm going to use a different color, circle the bottom one. I multiply the second fraction, top and bottom, by 4. And look what happens. To multiply fractions, it's top times top, bottom times bottom, so 3 times 3, 9. 4 times 3, 12. The second one, 2 times 4, 8. 3 times 4, 12. Now the denominators are the same, 9 twelfths and 8 twelfths. We can add the tops together. We get 17 over 12. Which we would never write as 1 and 5 twelfths. We will leave it like this. All right, next question. How do we add x over 2 plus 2 over x? exactly the same way. I'm even going to use the same colors. So I have x over 2. I'm going to multiply by the bottom of the other fraction. So I can divide by it. And then I have 2 over x. And I'm going to multiply by 2 and divide by 2. This forces the denominators to be the same and allows us to add the numerators. X times x is x squared over 2x plus 4 over 2x. We can now add the tops together, x squared plus 4 all divided by 2x. That would be our answer. Okay, and now the last one. How do we tangle with this? Well, we need to make common denominators, but the first part of the question has no denominator. Or does it? It does. There's a 1 hiding. Whenever you're missing a denominator, you can put a 1 there if you want. And now I'm just going to follow the same steps as before. I'm going to circle all this stuff in orange. So the first part, I'm going to have 3 over 1 multiplied by. It's important for this one to put brackets because the 3 has to be multiplied by the x and the 1, by everything in the bottom. Plus, oh, it's not plus, it's minus. Minus, I'll put brackets around this, 2x plus 3 over x plus 1. I'll put brackets around that too. Now I'm going to multiply and divide by 1. It's kind of a useless step because multiplying by 1 doesn't change anything, but I'm being consistent with the approach that was shown above. Alright, first one, 3 times x plus 1 is 3x plus 3, not 3x plus 1. The 3 is multiplied by both pieces. Second part, I have minus 2x minus 3 because that negative sign hits both pieces inside that bracket. That's why I put brackets around it. All divided by x plus 1 times 1. And we're not quite done. We have to collect like terms. 3x minus 2x is x. 3 minus 3 cancels. So I get x over x plus 1. Perfectly good answer. So I can tell you a trick for checking some of these calculations. One trick to make sure you simplified correctly is that if left-hand side is equal to right-hand side, it has to be true for all values of x. So pick a value of x. Like pick, let's say 0 for x in the last example. 3 minus 2 times 0 plus 3 over 0 plus 1. So 3 minus 3, 0. That's you get on the left-hand side. Now let's check the right-hand side. 0 over 0 plus 1, I get 0 divided by 1, which is also 0. So they agree with each other. Maybe check a different number. Maybe check... not sure. To think about it. I'll just check 2. So if I check 2, we get 3 minus 7 over 3. On the other side, it is 2 over 3, and then we have to do subtraction to make sure they actually equal each other. I'll let you do that. But it should all work out to be equal. And then that gives you some confidence that you did your steps correctly. Math is full of those types of things, ways that you can check your work. What is our plan for the class? We're going to start officially the new material with functions. Then we're going to move to limits. So that'll be what gets posted for next week. Throughout the course, we're going to do review of exponent laws because they're needed consistently. I'm going to post another review type of video for this week as well that will remind you of the laws of exponents. I know that I put out some statements that may have been concerning to you about the background that's expected. Don't panic if you're missing some of it. Don't panic if you've forgotten all of it. There's time to get help. but do get that help. Do ask for help if you need it. Anyway, see you in the next video.